So if we're combining everything, whether it's alkane, alkene, alkyne, aromatic hydrocarbons, which includes benzene and all of the functional groups, I want to make sure that we go through many examples that are all mixed up, because the other worksheet I give you, it's all like in categories. But this is all mixed up, and then we're going to identify what it is first, and then once we identify what it is, we can draw it. So the first one, 2-chlorobutane. Okay, a lot of clues here. We've got ane, which means it's single bond. Bute means that it has 4 carbons. And then chloro means it's an alkyl halide. I don't know why that looks weird. Black looks better. And then the 2 tells us what it's on. Oh, it looks like a pencil, but anyway. So first I'm going to draw a 4 carbon. 1, 2, 3, 4. All single bonds, so I don't have to worry about any double bonds. And then on number 2, I put a chlorine. Done. Okay. For part B, it's also bute, but now I've got an ene, and that means it's a double bond, and the 2 tells me that it's the double bond is on number 2. So again, I'll draw 4 carbons, 1, 2, 3, 4. And on number 2, going from number 2 to number 3, I put a double bond. I don't think it matters whether you put it on the top or the bottom. And that's that one. Part C, 2-ethyl 3-methylbutanol. Okay, this is my key. Turn this sideways. Keep some of them. Okay, so the OL is the clue that it's an alcohol. I've got AN, which means there's no double bonds or anything. Bute means 4. This number 1 is for my hydroxyl group. And then I've got 2 alkyl groups on number 2 and number 3. So I'll draw 4 first. 1, 2, 3, 4. On carbon number 1, that's where my hydroxyl group goes. So I'm going to do that. And then I've got 2 ethyl. So ethyl is 2 carbons and 3 methyl going down. For part D, it's an oic acid. That means it's a carboxylic acid. That means that you're going to have a carboxyl group, which is a C double bonded to an O and OH. And that comes at the end. And again, it's bute and it's an, so there's no other double bonds in there. So I draw 4, 1, 2, 3, 4. At the end, my double bond O and my OH. And then I've got 3,3-dimethyl. This counts as number 1 always. So you just have to count backwards. Or if you want, you can draw it 1, 2, 3, 4 and put it here. Double bond O, OH. I just like to put them at the end for some reason. I don't know why. But so that's 1 and then 2, 3,3-dimethyl. So you have 1 here, 1 here. For part E, I don't like this type of naming because without the AN or the EN or the YN, you don't know. I guess you assume it's an alkane derivative, because I would say this is heptanone to be more clear. But anyway, if you see heptone, then of course you assume it's just single bonds. Right, so one means it's a ketone. A ketone means we have a carbonyl group, which is a C double bonded to an O. And a ketone, the carbonyl group, occurs somewhere within the chain. This 4 is telling us exactly which carbon it's on. So I draw first hept, which is 7. 1, 2, 3, 4, 5, 6, 7. Of course, you don't have to make them that wide. I just make them wide so it's very clear. And then on number 4, 1, 2, 3, 4 is where my double bond O is. Of course, that should attach. And then I've got 2, 5, 5. So if that's 4, this is 5, 5, and 2. 2, 5, 5 trimethyl. For F, 1,8-nonadiene. Okay, now we've got a triple bond. We have two of them, which is on 1 and 8. And I've got nona, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. On number 1, I've got a triple bond. And number 8, I've got a triple bond. No alkyl groups. For part G, 1,3-diiodobenzene. Remember, benzene is an aromatic hydrocarbon. It's a 6-carbon ring. Put the circle in there. I always start at the top for I, and you can either go clockwise or counterclockwise, doesn't matter. Go clockwise, diiodo. I don't actually remember what ethoxy is. Let me look that up very quick. Since it's here, ethoxy, nope. Oh, okay, that makes sense. Oh, I didn't think of that. All right, so ethoxy is basically a combination of ethyl and oxygen. So it's CH3CH2O. Okay, so you get the ethyl and your oxygen, ethoxy. So that's the alkyl group. Didn't cover that because it wasn't in the book. I don't see it that often. Right, so then you just draw another benzene ring. And then here you would draw, you could do O and then do it. Yeah, I think that would do it. Although that might make it look like an ether. So maybe better not to do that. And you would do OCH2CH3. Yeah. All right, letter I, 1-butanol. It's another alcohol. Single bonds, 1, 2, 3, 4. OH. 3-methyl-2-pentene, double bond on the 2. 1, 2, 3, 4, 5. 2 and 3-methyl. All right, K, something we haven't seen yet. Al, pentanal, that is an aldehyde, which is a carbonyl group at the end. That was one thing that I noticed, I think almost everyone did in the homework, is that you started putting position numbers in front of al. So you were writing pentan 1 al, and you don't need this because the al by definition has to be on number 1. So there was no need to identify position number for that because that's what defines an aldehyde, is that is at the end. So I've got pentanal, 1, 2, 3, 4, 5. Put my double bond O, my H there. And then that has to be number 1. So then I count 2 ethyl, and 4 methyl, boop. 3-ethyl 2,4-dimethyl 3-hexanol. Hex is 6. 1, 2, 3, 4, 5, 6. On number 3 is the hydroxyl group. 2,4-dimethyl and 3-ethyl. Boop, boop. Or if you want to, you can flip the ethyl and the hydroxyl, doesn't matter. Letter M, 5-chloro, 3-ethyl, 2-methylheptanoic acid. Again, carboxylic acid. So that's going to be double bond O, OH at the end. Heptan means there's no other double bond. So hept is 7. 1, 2, 3, 4, 5, 6, 7. That's where my double bond O, boop, OH. This again automatically has to be number 1. So 2-methyl, 3-ethyl, 5-chloro. My ethyl's a little curvy. phenol. I think that's a benzene ring. Yeah. Okay. Phenol is when benzene is alkyl group. So we've got phenylbutane, 1, 2, 3, 4, and 2 phenols. So then I go up like this. So when benzene is a branch, it's called phenol. Ooh, naphthol, I think. Yep. Okay. So we have something called if I could spell it correctly. Naphthalene, I think it's naphthalene. Hold on. Yeah, okay. So there's another one called naphthalene, which is basically 2 benzene rings together. That's naphthalene. And then when you put all, that means there's alcohol, a hydroxyl. So we'll just go over here. So 2 naphthol. Wait a minute. What would you count as number 1 then? 2 naphthol. What does that look like? Oh, okay. So according to Google, it's telling me that 2 naphthol is this. So that must mean that that carbon is the default number 1 position. And then I just count around. So if this is 2, 3, 4, 5, 6, that would be 7. So it's 7 bromo. Boop, Br. You don't see these too often. And then if we can try to figure out what benzoic acid looks like, that must be a benzene ring, but with a carboxyl at the end, right? Because we got benz, and then oic acid means a carboxyl group, which is this. So if I draw benzene, that's what I mean. Like a lot of these things you can figure out if you understand the basis of what all of the parts of the name mean. So benz means a benzene ring. I've drawn that. And then it doesn't matter where I put my carboxyl group. So I just stick a carboxyl group anywhere, really. So OH, there's a double bond O. Let me redraw that because it's kind of close together. Okay, so I'm just going to stick it here because I don't know, I like that position. Double bond O. Right, then this automatically again makes it number 1. And I've got 4 bromo. So again, it doesn't matter which direction I go, either clockwise, counterclockwise. I just count to number 4, 2, 3, that would be 4. And I put a bromine here. Let's see if they have some naming. What do they do? All right, first thing, I just want to go through and identify what kind of compound these are, not necessarily the names right away. So for part A, we're looking for a functional group that will help us define what this is. So you should automatically see OH. And think, okay, that's a hydroxyl group. That means it's an alcohol. So I can just write alcohol. And then I'll come back and we'll come back and we'll name these, but I just want to go through and identify. Next one, you should be looking at this. That is a carbonyl group, which includes that. Oh, that's a bit thick, isn't it? Let's make it a bit thinner. There we go. The carbonyl group includes that carbon It's in the middle, which means this is a ketone. For part C, there's nothing outstanding. It's all carbon and hydrogen. So you're only going to be looking at the double bond, which means it's an alkene. Go over here. Obviously, this is going to be our functional group. So then we have to figure out what is that. It is a C double bonded to an O, but it's at the end of the compound. There is no hydroxyl group here, so it's not a carboxylic acid, it's an aldehyde. For part E, again, you've got this little alcohol hydroxyl group at the end, so that's also an alcohol. And for part F, also an alcohol, but also we've got 2 double bonds, so that might be a bit more complicated. Oops, alcohol. So we've identified what they are. Let's go back and name them. So first thing we want to do is find the longest chain. So we can either go straight across or we can go across and down. But again, either way, you're going to have the same number of carbons, and either this one or that one's going to be a function, an alkyl group. They're both on the same carbon, so it does not matter at all which way you choose. But again, I like to be nice and neat. We're just going to go straight across. We're going to count the number of carbons. 1, 2, 3, 4, 5. 5 is pent. So we've got pentan, because there's all single bonds, and pentan, the way that I like to do it personally is put position numbers in front of the thing that we're identifying where it is. So the ending is going to be all. I'm going to say which carbon it's on. So I've got either 1, 2, 3, 1, 2, 3. Okay, it doesn't matter for the functional group which direction you number from. So what's the next step? If it doesn't matter, then you're going to go in the direction that will give the alkyl group the lowest number. So going from left to right, that gives this a 2. So it's pentan 3-ol, and I've got 2-methyl. For part B, again, we're going to go straight across. You can go and stop at this carbon and go down, but it's the same story as the last one. That wouldn't matter. Ketone, so the ending is going to be -one, and because it's a ketone, you have to tell me which carbon it's on. And this is a 1, 2, 3, 4, 5. This is pentan 3-one, because it's either 1, 2, 3 or 1, 2, 3, doesn't matter. But we're going to count from right to left because that will give our methyl group a lower number. So 2-methyl pentan 3-one. For part C, it's just an alkene. So I go straight across. Again, with the little methyl group, they're trying to be tricky, but it's the same thing. It doesn't matter. So it's 1, 2, 3, 4. But-1-ene. Okay, now in this case, you have to start counting from right to left because your priority is what defines this compound, and the double bond is what defines it as an alkene. So the double bond gets the lowest number. Therefore, your methyl group is on number 3. 3-methyl-but-1-ene. See if I can finish these 3 in 3 minutes. For the aldehyde, again, you do not have to have a position number for the carbonyl group because it will always be number 1. There are no alkyl groups here, so you just straight up name 1, 2, 3, 4 butanal. Okay, you don't have to say butan 1-al because the al tells you it's on number 1. Part E, 1, 2, 3, 4, 5 is pentan 1 ol, because this is what defines the type of compound it is. And so that has to get position number 1, which means we're going from right to left. So 1, 2, 3, 4. I've got 4, 4 dimethyl pentan 1 ol. And finally, something a little bit more challenging. It is an alcohol. There are 2 double bonds and there's a methyl group. So if I go, and this is my parent, I've got 1, 2, 3, 4, 5, 6. 6 is hex. So it's hex and then 1, 2, 3, or 1, 2, 3, 4. So I'm going to go 1, 2, 3, and then 4. So my double bonds are on 1 and 4. So that's hexa 1, 4 diene. I'll cut off the last E because I have to make room for my ol. And my ol is on 3 ol. Okay, hexa 1, 4 diene 3 ol. And then my last step is 3 methyl. 3 methyl hexa 1, 4 dienol.